Hi, and welcome back to another AP Pre-Calculus video. Today we'll be going over topic 2.13 of exponential and log equations, inverses, and inequalities. So this is probably only going to be part 1 since it's pretty long. So before we get started, we want to make sure we know the properties of exponents and the properties of logs. So exponents, when we multiply them, we make sure we add the exponents. When we have an exponent to another exponent, that's where we would multiply the exponent. And if we have a negative exponent, we never want a negative exponent, so we change it into a fraction that looks like this. So yeah. Then properties of logs. That was basically 2.12, if you guys remember. Basically that if we have the logs adding, then these values, which are the a values, if we look down here, that's the a's. We do have to remember the way exponential and logs are formed or written. So if we add them, then we multiply them right here. Then if we subtract log graphs, then we divide them. Then here's the power property, basically saying that if there's a number in front of the log graph, then we want to move it over to become the exponent of the a value, because we don't want a number in front. A, B, C, like in ABC alphabet, of course. Then the log, we can remember B as in the base, and we can remember it equals to C by remembering that exponential is equal to A, because they can't equal the same thing. If you can remember your ABCs, then I guess it won't be that hard. But yeah, you can mistake it sometimes, I guess. Just if you forget the log, try to remember the exponential. If you forget the exponential, try to remember the log, I guess. Now, solving equations with only one log or exponential function. Here are the steps that they tell us. First, we want to isolate the exponential or log expression on one side of the equation. So while I am reading this, I guess I will solve the first one. So we want to isolate. We see there's an exponential expression right there. So let's isolate. 4 to the power of x is now equal to 9. Now we isolate that. Number 2, there's a blank there. It should be switch the equation to the alternate form, exponential to log or log to exponential. So right here we see we have an exponential. So this entire thing is exponential, right? So we know a log is ABC. So 4 is B. We know log is log base, so that's B. And then it should equal to C, so that means right here is A. So to convert that, we need to change the positions of all the letters. So let's see, log B is 4. Let's see, A is 9, and then C is X. So that's our answer for the first one. Yes, it was solved for the variable, and then I guess if we need to simplify around this answer, we would do that. So let's move on to the next one. Let's isolate. That's 21. Now we want to switch this into log form. To make it easier, we can always write the forms down. That's exponential. And then log is B, A, C. So log B, which is 2, and then A is 21, is equal to x plus 3. But we don't have the variable yet. It's still not solved yet. So now let's isolate x. So minus 3. So we would minus 3 with this entire log equation. So now x is equal to log 221 minus 3. Now C, this right here is the log, so we want to isolate that. So we can minus 3 on both sides. It's negative 10 is equal to negative 4ex. And we can divide this right here. And that will give us a fraction, but it's going to be a positive fraction because of the 2 negatives. So 3 over 2 is equal to e to the power of x. That looks like an exponential form right there. So now we can change it to log form. So I'm going to write log b, a is equal to c. So log b, this is A, B, C, B is E, log of E, now it's A, 3 over 2, and if you want, you can write parentheses there to, like, you know, it might make it easier for you. And then it's equal to C, which is X. That's what we were solving for, and that's our answer. So now we're moving on to example 2. So, this is solving with the log now. So isolate. I know you're thinking that we can move this up here, but it's a lot simpler if we just divide. So we're just gonna do that. That will give us 3. And now this is the entire log, which it's log B, A is equal to C, and now we want to change it to exponential. So we can get X, or eventually lead us to solve X. So B is 3, so we have 3 to the power of C, which is 3 again. And then A is this entire thing, so X plus 3. We know this, 3 to the power of 3 is 27, so that's equal to X plus 3. And now we can solve for X. So X is equal to 24. Now, moving on to the next one, let's isolate and change that to an exponential form. This is B, A, and C. So 5 to the power of 2 is equal to 2x minus 1. This goes to become 25. Then we can solve for x. 26 is equal to 2x divided by 2 each time. And that will give us 13 is equal to x. Or x equals to 13. Sometimes I like to switch it because I can see it better. But you do you. Now we have here to isolate the log. We want to multiply each side by 5. And this right here, we can simplify that. We can say it's log E, so we can see like all the variables better, that E is equal to B. Because here it's just kind of like hidden in there. But if I write it like that, you can see it. So hopefully that helps some of you guys. And so now we know that this is B and this is A and this is C, so changing it into an exponential would be e to the power of 5 is equal to 2 minus x, and now solve for x. So and that's our answer right there. And when we divide by the -1 right here, it changed this to negative, but changes 2 to positive because that's 2 negatives right there. And then we get this answer. So now moving on to equations with multiple logs. This is basically telling you how you can solve it. Basically, all you have to do, remember 2.12, if it's addition, subtraction, whatever, we do what we're supposed to, and then because they have the same log base, we can essentially just take away the log and then just solve for x with what was inside the parentheses, or aka the a value. So let's do this, for example. So all of this is log 10, so we will do that. So this is addition here, so we want to multiply 3 and this term, so 3x plus 4, and that's equal to log of that, so I just moved that down. So now because it's both 10, so we can just take that out, and then we can equal it to each other. Make sure to distribute that, and then we can solve for x from there. I like to keep x positive because that's just like, I don't know, it just feels cooler, I guess. Plus 2, and that equals 14 is equal to 2x divided by 2. So x is equal to 7, or 7 is equal to x if we're on the same side, didn't switch, but yeah, same thing. Now let's do the same thing here. So these all have ln. This is subtract, so we're going to be dividing these two here. So ln x plus 1 divided by 3x minus 5 is equal to ln 7. So now we can take away the log. So you go to 7. And we can basically multiply each side by this. So you can either do that or change this into a fraction and then do the butterfly method. Whatever works best for you, I guess. And now we can solve for x here. So minus x, 20x minus 35, but plus 35 to both sides. That would be 36 is equal to 20x. And then divide 36. Oh, sorry, not 36. Divide 20. And that will give us 36 over 20 is equal to x. But we can simplify that. Let's see, we can divide this by 4 and divide this by 4. That gives us 9. That's a 9 under g. 9 over 5 is equal to x. Now, see, this is addition, so let's multiply. Looks like this is going to be a quadratic, though. More math, but that's okay. So let's do this. And then we can take away these logs. Take away x squared minus 3x plus 2x. And then minus 6. That gives us negative 3 plus 2 is negative x plus minus 6 is equal to 14. So we need this to equal to 0, so we can move the 14. So that gives x squared minus x minus 20 is equal to 0. And then to solve for x, what two numbers give multiply to negative 20 but add to negative 1? Looks like that would be negative 5 plus 4. Yep. And now we have two solutions there. X is equal to 5. This is 5 and this is negative 4. Okay, so I did forget one thing. When you're doing these questions, you do want to check for the domain because you might get multiple solutions or solutions that might not work, and then it'll end up giving you no solution. So to check the domain, you can go back up here. Basically this problem is like an example of this one important note that we got up there. Basically, we need to check for extraneous solutions. So basically, one of these might not work. So we need to find out the domain of the original equation. So when we look back at the original equation, we need to set these to greater than 0, so they're all greater than 0. We don't have to do this one since there's no x. And then we solve for x. So x would be greater than negative 2 because we subtracted 2 here. And then the other one would be x is greater than 3, added x. So that's basically our domain. But the more restricted one is this one. It has less values because let's say it's greater than, right? And so it goes up to infinity. This one will have less values, but only 5 less values, or 6 is that? Well, this one would not include negative 2. It would include negative 1, 0, 1, 2, and 3. That's 5 extra. But this one right here would not include those. So this one right here is the more restricted one, and so we use that one. But basically, if the domain was greater than 3, this one doesn't work. So we cross that out, and so our answer is x is equal to 5. Now moving on to this one right here. Honestly, I recommend that I think it would probably be better to check the domain first for every problem, but that does take off some time. But most of the times, you will know that it doesn't really work because it's negative, and an a value for the negative doesn't really work. So moving on to this one. We're subtracting, so we're dividing. But this one right here is not in log form. So we can't make it x over 3 is equal to 2 because this right here is not in log form. So we don't want to do that. but we can see it's in this form already. So we can change it to an exponential. X over 3 is equal to log, this is log e, so it's e to the power of 2. So we can solve for x. This right here, basically 3e to the power of 2. So x is equal to 3e to the power of 2. Now moving on to example 4. So this one is really telling us to check for extraneous solutions. So this one's going to be pretty important to check for the domain. So let's go ahead and start with A. It's subtract, so we're going to go ahead and divide. Oh, we need to move this over here to the front. So that would give us, this right here is 8. We can change it to 8. So it's x divided by 8. Okay, now we can equal it to each other. I'm going to multiply both sides by 8. And then solve for x. Alright, so they gave us a negative number. So now let's go ahead and check with the domain. So, this one has an x here, and this one too. So we can check the domain with these two. So, if we both make it both greater than 0, this one would become x is greater than negative 7. This one is x is greater than 0. So looks like this one is the more restricted one. 0 is greater than negative 7, so it has less values. This one has less values, so is therefore more restrictive, and so we're going to use that. X needs to be greater than 0, so that means this is not a solution. This is the only answer we got, but it's not working. That means we have no solution. And either way, this doesn't work. Either negative 8 is less than negative 7. So our answer is no solution. So moving on to B. This is addition. So let's multiply. I like to write 10 to know the base. They're equal, but you know, maybe that's a waste of time. So I made a mistake there. I forgot to move this to the front again. So that's the same thing as last time. Makes this 8. Alright, and then we'll X that out. Or I'm actually gonna do this. X divided by 8. Oh, sorry. It's x times 8, which is basically 8x. Looks better, so I'm gonna do that. Then log 10. Then we can equal to each other because they both have the bases and the log. Now solve for x. X is equal to negative 7 over 6, which is a negative number, and it's less than 0. So let's check the domain. Looks like that is x is greater than 0. Already not off to a strong start. So it looks like since this one, no matter whatever this one is, if it's like x is greater than negative 2 over 7, this would be more restrictive. If this number is greater than 0, this would be more restrictive, but it's a positive number, which already makes this not work, so we can already tell it's no solution. So do this though. That's plus 7. We got 7 divided by 2. So x is greater than 7 over 2, which is like 3.5. So this is more restrictive right here, this one right here. I'm going to circle green for the more restrictive one. And yeah, it's this solution is not part of it then. So looks like this one is also no solution. So now example 5. Let f of x right here and let g of x equal to that, yep. And find all the values of x where graphs of f and g intersect. So I don't know if you guys are allowed to use calculator, but I guess you can use calculator and find where it intersects there. But if we were to solve it, and we want to find the intersection is just them being equal to each other. So let's write that. Now let's solve it like the previous ones we did, where we can change it to solve for x, or like, you know, take away the logs. So this is divide. Now let's change it. Get rid of the logs. I'm going to multiply each side by x. Looks like we have a quadratic here, x squared plus 3x. So I'm going to subtract this x and subtract 10. That gives us x squared. Actually, I'm going to move it to the top here so it makes more sense. X squared plus 2x minus 10 is equal to 0, so let's do that. What adds to 2 but multiplies to negative 10? So it looks like nothing works, so we would have to use the quadratic formula. So this is I'm gonna write the quadratic formula in this corner. Hopefully you remember, like use a song or anything. Now we can plug in our values. Remember, this is A, B, and C. I like to do this first, so let's do that. It's like 4 minus 4 plus 40. Negative 10 times negative 4 for 2. It gives us square root of 44 over 2. Square root of 44 can simplify to 4 times 11. So that's 2 times the square root of 11. And then I'm going to move that over then. Over 2. That looks like, and that seems like it would equal negative 1 plus or minus square root of 11, because this becomes 1 and this becomes negative 1. That gives us two versions, a negative version and a positive version. So negative plus square root of 11 and negative 1 minus square root of 11. So x is equal to these two versions, right? These two versions, but which one actually works, or maybe both of them works? We have to check the domain. So let's look back to the original one. This right here was the original equation. All of these will give us a domain. Let's look at the first one. That's x is greater than negative 10. The second one is x is greater than 0. The third one, x is greater than negative 3. The most restrictive one is going to be this one right here, the second one. So let's look back into here. Whatever square root of 11 is, we know it must be greater than this, the square root of 9, because we know what the square root of 9 is. That's 3. So it's greater than 3. So let's say negative 1 plus 3, that gives us 2. That's a positive number. So we know this one right here, this answer must be greater than 2, which is greater than 0. But this one right here must be like negative 1 minus 3 point something, right? But that gives us negative 4, which doesn't work. This does not work right here. So it looks like this is our only answer. That's very tedious work. So moving on to example 6, we have h and k here. What are all the x-coordinates of the points of intersections of these two graphs? So we're going to do the same thing. Eight x plus 2. So this is addition. So we're going to multiply. I'm just going to go ahead and not write the logs. So we do have to distribute FOIL there. And now we're going to move all of this to the side so it can equal to 0. That's 2x squared minus 3x minus 14 is equal to 0. Okay, so there's a number in front of the x squared, so we want to do slip and slide method, if you ever heard. Basically, we slide this 2 to multiply to 14. That would give us x squared minus 3x minus 28. And now we use this to find what adds to -3 but multiplies to -28. That looks like it's -7 plus 4. But because we multiplied that 2 earlier, now we want to get it back and divide it. That will give us 2x minus 7 and then x plus 2. So these two are our solutions there. Let's see. This one gives us, we equal 0 on both of them. Looks like this is add 7 divided by 2, so 7 divided by 2. This one's minus 2, so that gives us -2. This is already a negative number, so don't assume in math, but you know, negatives don't work. So let's go back to the original to find a domain. So it looks like we want to find a domain here, here, and here. So 2x minus 3 is greater than 0. That gives us x is greater than 3 over 2. X plus 4. That gives us x is greater than -4. And then 8x plus 2. X is greater than -2 over 8, which is 1 over 4. So the most restrictive one is this one right here because this number is the largest. So which one is greater than 3 over 2, which is basically equal to 1.5 in decimal form. So this one's a negative. This one right here, we know 6 divided by 2 is equal to 3, so 7 divided by 2 is 3.5. So it looks like x is equal to 7 over 2 is our answer. That looks like a z. It's a 2. Now, equations with multiple exponential functions. When we solve these, all we have to do is make sure the base is the same. Similar to the log graphs, we had to have the logs the same in order to equal these two, right? We need the base the same, so we can just simply solve those two. So for this example, the bases are already the same, so we can set them equal already. And then solve for x. That's 3x is equal to 8. So x is equal to 8 over 3. Now, this, for example, doesn't have the same bases, so we can change one of the bases. So we know we can change this 8 right here to 2 to the power of 3. But that 3 then would multiply to the entire equation up there. So now the bases are the same, but the equation did change though, which makes sense. It has to change if we do change it. So it looks like it's 2 to the power of 9x minus 6 is equal to 2 to the power of x plus 5. And then we can solve it there. 9x minus 6 is equal to x plus 5. X is equal to 11 over 8. Okay, so we have here. We know, so it looks like 9 we can't really like have 9 to the power of something would give us 27, or yeah, it's just, we can't do that. But we do know that 9 is a square of 3 and 27 is the cube of 3. So we can change both of them to 3. So 3 to the power of 2, that gives us 9. And for 27, we can do 3 to the power of 3. That gives us 27 too. So now change that. 3 to the power of 4x is equal to 3 to the power of 3x plus 6. Then 4x is equal to 3x plus 6. That's x is equal to 6. That one was not bad. So now this one. We can try to change both of them to 2. We have this 2 to the power of 2 to change this one to 2. Or, so 2 to the power of what can give us this, right? That's how we can get 2. 2 to the power of what? Remember back to having negative exponents, right? If we had 2 to the power of -1, we need to put the positive version, so 2 to the power of 1 under 1. 2 to the power of 1 is basically 2, so it looks like to get 1/2 using 2, it's 2 to the power of negative 1. So we can multiply that right there. That's kind of small, but you know. So 2 to the power of negative 5x minus 7 is equal to 2 to the power of 2x, and then we can equal the exponents. So solve for x. Divided by 7. X is equal to 1. What a simple answer for, a not easy question. But yeah, that was part 1 of 2.13. Stay tuned for part 2.